Alright, so we're going to discuss the operations on radicals. So, remember that there are four fundamental operations: addition, subtraction, multiplication, and division. So, today we're going to learn how to use that operation or those operations on radicals. So, let's start first with addition and subtraction. We add or subtract radicals by combining like radicals. Like radicals are those which have the same index and radicands. Let's start with the first example. So, see here we have 3 square root of 5 plus 7 square root of 5. Notice that they are like radicals. Okay. So, why? Because first, the index is 2. Okay, both are square root. And the radicands are both 5. So, how are we going to add them? So, all we need to do is to combine their coefficients. That is 3 plus 7. And then we copy the radical, square root of 5. So, 3 plus 7 is 10, square root of 5. That is our answer. Next. Alright, so we have here 3 square root of 7 plus 5 square root of 6 plus 4 square root of 7 minus 2 square root of 6. Notice, class, that there are like radicals, a pair of like radicals. So, let's see. All of these radical expression or terms, each term has the same index. That is, the index is 2. So, square root of 7, square root of 6, square root of 7, square root of 6. But the radicands are not the same. Here we have square root of 7 and the first one we have square root of 7, the first term. Second term is square root of 6. The third term has square root of 7. And then, the last term has square root of 6. So, all we need to do is to combine those which are like terms. 3 square root of 7 and 4 square root of 7. Also, 5 square root of 6 minus 2 square root of 6. And then we combine. So, we combine first 3 square root of 7 plus 4 square root of 7. So, that is 3 plus 4 square root of 7. And then, plus 5 minus 2 square root of 6. So, we have 3 plus 4, which is 7, square root of 7, plus 5 minus 2 is 3, square root of 6. And this is our answer. 7 square root of 7 plus 3 square root of 6. How about this? The given is 4 square root of 50 minus 2 square root of 8. Again, they have the same index. The terms have the same index, which is 2, because they are both square roots. But notice that the radicands are not the same. We have square root of 50, the radicand is 50, and the other one is 8. But we can simplify both of them. So, we need to do that first in order for us to perform the operation. So, we write 4 square root of 50 as 4 square root of, and think of two numbers that when you multiply is equal to 50, or the factors of 50. One of the factors must be a perfect square, and that perfect square must be the largest perfect square. So, in this case, that would be what? 25 times 2 minus 2 square root of, again, we can simplify 8. we think of two numbers, okay, when you multiply is 8, and one of those numbers is a perfect square. So that would be 4 times 2. Alright. Okay. Next, we write again 4. This is the coefficient of the first term. Now, we simplify square root of 25 times 2 by, okay, extracting the square root of 25. And the square root of 25 is 5. Square root of 2, because 2 will remain inside the radical sign. Minus 2, and then the square root of 4. To simplify, we take the square root of 4. The square root of 4 is 2. And then, square root of 2 will remain inside the radical. Okay? And then we have 4 times 5 is 20. Square root of 2 minus 2 times 2 is 4. Square root of 2. Now, we can combine, because they are already like terms. 20 square root of 2 minus 4 square root of 2. So, we have 20 minus 4 square root of 2. And the final answer is 16 square root of 2. Alright. Finally, we have here square root of x to the 5th minus square root of x cubed. Again, we factor this, and one of the factors is the largest perfect square. So, we have square root of x to the 4th, because x to the 4th is a perfect square, times x minus square root of x squared times x. Okay. Next, we simplify the expression. X to the 4th, we can extract the square root. And the square root of x to the 4th is x squared. So, that would be x squared square root of x minus, and then we do the same for square root of x squared times x. So, that would be x square root of x. Now, we have like radicals. We can combine. So, this is now x squared minus x square root of x. Now, x squared minus x, we cannot combine. So, this is now our final answer. Alright. So, that is how we add or subtract radicals. We move on to multiplying and dividing radicals. So, in multiplying and dividing radicals, we multiply or divide radicals by multiplying or dividing the coefficients and multiplying or dividing the radicands. Then, we simplify the expression. Let's have some example. Oops. So, we have something like this. Square root of 8 times square root of 10. So, all we need to do, since both of them are the radicands, are in the inside, okay, inside of the radical sign, all we need to do is to combine them. Or we multiply them. Okay, so we have not combine, multiply. So, we have square root of 8 times square root of, square root of 8 times 10. So, that would be square root of 80. And then, we simplify. So, we think of factors in which the first factor, one of the factors, is the largest perfect square. We can say that would be 8 times 10. But 8 is not a perfect square. Let us write that down. 8 times 10. But 8 is not a perfect square, and 10 is not a perfect square. So, these are not what we are looking for. Okay. So we are looking for a perfect square, and that perfect square must be the largest. So we have what? It should be 16 times 5. Alright. And the square root of 16 is 4. So we take it outside, or we simplify it by extracting the square root of 16, which is 4. And then square root of 5. So this is now our final answer. How about number 2? We divide. Okay, so this is now 72 divided by 6. Is it divisible? Is 72 divisible by 6? Yes. Okay, since this is divisible, we just write, we write square root of 72 over 6, which is square root of 12. And then we simplify. 12 can be factored, one of which is the largest square factored, and that would be 4 times 3. And then we take the square root of 4, which is 2, and then square root of 3. So this is the final answer. How about number 3? So that would be square root of 8 xy cubed over square root of x to the 5th. So the first thing that we notice is that we have a square root on the denominator, but we need to get rid of it by multiplying both the numerator and the denominator by a number that would make the denominator complete, or we have to rationalize the denominator. So we copy first 8xy cubed over square root of x to the 5th, and then we multiply it by x, square root of x over square root of x. So we have square root of 8, and then we have x squared y cubed. The denominator becomes square root of x to the 6. So we need to simplify this by extracting again the, not extracting, but we are going to write the factors. One of the factors must be the largest square factor. So 8 first. So what are the factors of 8 again? So that would be 4 and then 2. X squared is a perfect square, and then y cubed. Okay, so we have y squared, and then here we have another y. So these are your factors. All over, okay, x to the 6, we can extract already the square root, which is x cubed. Okay, so we now have 2xy square root of 2y over x cubed. And the final answer, when we simplify, we cancel x, and then this becomes x squared. So this becomes 2y square root of 2y all over x squared. So this is now our final answer. Okay? So see you in the next meeting. Goodbye.